Bathroom ground fault circuit interrupter, or GFCI, outlets are indeed considered appliance circuits when calculating apartment loads for wire size. The reasoning behind this classification stems from the typical usage of these outlets. They are commonly used to power various appliances, primarily those found in a bathroom environment. These appliances include hairdryers, curling irons, electric toothbrushes, and similar devices. Because these outlets are intended to serve appliances, the electrical code considers them as part of the overall appliance load calculation for a dwelling unit. When determining the appropriate wire size for a circuit, it's essential to account for the anticipated current draw. The National Electrical Code, or NEC, provides guidelines and tables to ensure the safe and efficient distribution of electricity. When calculating the total load on a circuit, one must consider all connected devices and their respective power consumption. For bathroom GFCI outlets, this means including the expected load of the appliances that are likely to be plugged into them. Failing to account for these appliance loads can lead to undersized wiring, which can create several problems. Firstly, undersized wires can overheat when carrying a current that exceeds their capacity. This overheating can damage the insulation surrounding the wires, potentially leading to short circuits or even fires. Secondly, an overloaded circuit can cause voltage drops, which can affect the performance of the appliances connected to the circuit. Appliances may not operate at their full capacity, and some may even malfunction due to insufficient voltage. Thirdly, an overloaded circuit can trip the circuit breaker, causing inconvenience and disruption of service. Frequent tripping of circuit breakers is a sign that the circuit is being overloaded and needs attention. To ensure the safety and reliability of the electrical system, it's crucial to accurately calculate the total load on the circuit and select the appropriate wire size. The NEC provides specific guidelines for calculating appliance loads, and these guidelines should be followed carefully. In general, the calculation involves determining the wattage or amperage of each appliance that is likely to be connected to the circuit and then summing these values to obtain the total load. Once the total load is known, the appropriate wire size can be determined using the NEC ampacity tables. These tables specify the maximum current that a given wire size can safely carry under various conditions. It's important to select a wire size that has an ampacity rating that is equal to or greater than the calculated load. In addition to considering the appliance loads, it's also important to consider the continuous load on the circuit. A continuous load is defined as a load that operates for 3 hours or more at a time. For continuous loads, the NEC requires that the circuit breaker and the wiring be derated to 80% of their rated capacity. This means that the circuit breaker and the wiring must be able to handle 125% of the continuous load. For example, if a circuit has a continuous load of 16 amps, the circuit breaker must be rated for at least 20 amps, and the wiring must be sized to handle at least 20 amps. This derating is necessary to prevent overheating of the circuit breaker and the wiring. When calculating apartment loads for wire size, it's important to consider all of the circuits in the apartment, not just the bathroom GFCI outlets. This includes lighting circuits, general receptacle circuits, and dedicated appliance circuits. The NEC provides specific guidelines for calculating the load on each type of circuit. For example, the NEC requires that general receptacle circuits be calculated at a minimum of 3 volt amps per square foot of floor area. This ensures that there is sufficient capacity to handle the expected load of portable appliances and electronic devices. For dedicated appliance circuits, the load is calculated based on the nameplate rating of the appliance. The nameplate rating is the maximum power that the appliance is designed to draw. It's important to use the nameplate rating when calculating the load, even if the appliance is not always operated at its maximum power. Once the load on each circuit has been calculated, the total load for the apartment can be determined by summing the loads of all of the circuits. The service entrance conductors, which are the wires that bring electricity into the apartment, must be sized to handle the total load. The NEC provides guidelines for sizing service entrance conductors based on the total load. It's important to select service entrance conductors that are large enough to handle the expected load, even if the load is not always present. This will ensure that the electrical system is able to meet the demands of the apartment's occupants. In summary, bathroom GFCI outlets are considered appliance circuits and must be included in the calculation of apartment loads for wire size. This is because they are typically used to power appliances such as hair dryers, curling irons, and electric toothbrushes. Failing to account for these appliance loads can lead to undersized wiring, which can create several problems. To ensure the safety and reliability of the electrical system, it's crucial to accurately calculate the total load in a circuit and select the appropriate wire size. The NEC provides specific guidelines for calculating appliance loads and sizing wires, and these guidelines should be followed carefully. When performing electrical work, it's always best to consult with a qualified electrician. Electricians have the knowledge and experience to ensure that the work is done safely and in accordance with the electrical code. Attempting to perform electrical work without proper training can be dangerous and can lead to serious injury or property damage. Furthermore, improper electrical work can create fire hazards and other safety risks. It's also important to note that electrical codes and regulations can vary from one jurisdiction to another. It's essential to be familiar with the local electrical code and to follow it carefully. The local electrical code may have specific requirements for bathroom GFCI outlets, such as the type of GFCI protection that is required and the location of the GFCI outlet. In addition to following the electrical code, it's also important to use high-quality electrical materials. Cheap or substandard electrical materials can be unreliable and can pose safety risks. It's always best to use electrical materials that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL-listed electrical materials have been tested and certified to meet safety standards. When installing bathroom GFCI outlets, it's important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific information about how to install the GFCI outlet correctly. It's also important to test the GFCI outlet after it has been installed to ensure that it is working properly. A GFCI tester can be used to test the GFCI outlet. The GFCI tester will simulate a ground fault and should cause the GFCI outlet to trip. If the GFCI outlet does not trip, it is not working properly and should be replaced. Bathroom GFCI outlets are an important safety feature in bathrooms. They are designed to protect people from electric shock. Ground faults can occur when electricity takes an unintended path to ground, such as through a person's body. GFCI outlets are designed to detect ground faults and to quickly interrupt the flow of electricity. This can prevent serious injury or death. In addition to bathroom GFCI outlets, there are other types of GFCI protection that can be used in homes and businesses. These include GFCI circuit breakers and GFCI receptacles. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. GFCI receptacles are installed in place of standard receptacles and provide GFCI protection for that particular receptacle. GFCI protection is required in many areas of the home, including bathrooms, kitchens, and outdoor areas. The electrical code specifies the areas where GFCI protection is required. It's important to ensure that GFCI protection is provided in all of the required areas. GFCI protection is an important safety feature that can help to prevent electric shock. Electrical safety is a serious matter. It's important to take precautions to protect yourself and others from electric shock. Always turn off the power before working on electrical equipment. Use insulated tools when working on electrical equipment. Never touch electrical equipment with wet hands. If you are not comfortable working on electrical equipment, hire a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. By following safety precautions, you can help to prevent electric shock and other electrical hazards. Remember to consult the National Electrical Code, or NEC, for the most up-to-date guidelines and requirements related to electrical installations. The NEC is a comprehensive set of standards that covers all aspects of electrical safety. Staying informed about the NEC is essential for anyone who works with electricity. It is also recommended to be knowledgeable about local amendments to the NEC that apply to your area. These amendments may reflect specific local conditions or regulations that are not covered in the national code. Always prioritize safety and seek guidance from qualified professionals when dealing with electrical systems. Electrical work requires expertise and careful attention to detail to ensure the safety of people and property. Furthermore, proper documentation and permitting are often required for electrical installations. Be sure to comply with all applicable regulations and obtain the necessary permits before starting any electrical work. This will help to ensure that the work is done in accordance with the code and that it is inspected by qualified professionals. In conclusion, understanding the role of bathroom GFCI outlets in apartment load calculations is crucial for ensuring electrical safety and compliance. By following the guidelines of the National Electrical Code, using high-quality materials, and seeking guidance from qualified electricians, you can help to create a safe and reliable electrical system. And remember, regular inspections and maintenance of electrical systems are essential for preventing problems and ensuring long-term safety.